Whether we are there or not, ITSP Magazine still gets the best stories. Plenty of conferences and events spark our curiosity and allow us to start conversations with some of the world's brightest minds. In person or virtually, Sean Martin and Marco Ciappelli go on location and sit down with them at the intersection of technology, cybersecurity, and society. Together, we discover what the synergy of these three elements means for the future of humanity.
And hello everybody, you're very welcome to a new On Location with Sean Martin. I'm coming to you from Lisbon at OWASP AppSec Global. And we're here for a few days talking about all things AppSec, DevSecOps, and securing the applications that run our businesses and connect us consumers and citizens together. And it's a big challenge. We're not just talking web apps, we're talking mobile apps, there's cloud, there's containers, all kinds of fun stuff. And of course there's another hot topic that runs through everything, which is AI, which of course touches on data and brings with it a host of challenges around ethics and laws and all kinds of fun things. I had the pleasure of meeting Oleg Shanyuk, and I'm thrilled to have him here. Welcome, Oleg.
Thanks, Sean, nice to meet you here. That's my first time to OWASP as well. I'm pretty new to the security world, and even it was my hobby for a long time. Now it shifts to professional activities, and also OWASP as a community. I'm learning it. I'm super thankful for many documents on which actually I started to build a foundation of my own knowledge and understanding. So that's awesome.
Yeah, it's an amazing community, and I know we've crossed paths many times over the last couple of days, and we continue to meet people and introduce each other to folks, and as you pointed out, there's the conversations, and then I know some folks referred you to some resources as well that you just mentioned, some documents and things which are super helpful, and that's why I love this community and these events. And you and I, we had a chat the other night where I don't even know how many topics we discussed, but we were talking about power and AI and platform engineering and precision coding and all these things. And I was like, oh man, I wish we'd recorded that conversation, because there's so many far out there points that we were talking about. So we'll see how much of that comes back up in our chat today. One of the things, and if people listen to the pre-event chats on the road that I did with some of the keynote speakers, it was a lot about AI and different facets of it. There's building, there's using, there's running, there's protecting, there's using it to run and using it to build and using it to protect. And of course there's the security aspects and the audit and the legal, as I was mentioning earlier. So a lot of talks on that, and just came out of a keynote from Rob Vanderveer, and he made a couple points, and we'll start with this and we'll see where we go. But he made a couple points on the role of AI writing code, and in comparison to a human writing code. And the 2 points that he made that I hung on to were, one, AI could write code faster than a human, but it won't have the ability to have the sense of a human as it's writing the code. And he likened it to, he gave two examples. One, a basketball player knows the feeling of a double dribble.
Okay.
And a soccer player knows to keep their arms out of the way so they don't hand touch the ball. AI doesn't have that sense necessarily when it's writing code. It's gonna produce something that seems accurate, and it may be accurate, but it might be faulty in that
it goes through the ball.
Yeah. So that was one point. The other point was that because you are relying on a machine to write the code, and because of these challenges that that it might have in the code that it generates, you have to have a human there to validate it. And that human might need deeper skills to code review the code the machine wrote versus the code that they would write themselves. If they write it themselves, they kind of know how they wrote it, why they wrote it that way, and can then code review a human-generated piece of code based on that. And a machine might produce something that might be harder for a human to validate, or the human might need deeper understanding of the code to validate it. So the other point he made is you might write code faster, but the review skill set would need to be deeper, and the review process might take longer. So those 2 points were very interesting to me, and so I don't know, any thoughts from you based on that and your experience thus far working with it?
Yeah, as we speak, actually, it's a little bit off topic. Then I would like to come back to these 2 questions.
Okay.
So as we speak, and recalling the AI able to generate so much code, etc., and how a human can handle that. I'm recalling a talk from 2011, maybe.
Okay.
It's sort of the parody. Let me please quickly find a name. So basically, maybe you also know him. Worried Dream, Brett Victor. A guy. He basically, there's some talks of him, but I think the most recent, maybe still from the previous decade, and now he's stealth. He's working on a product which use a lot of AI, and basically he says maybe computer is not what's in your pocket, but it's more like the environment you go in to work on your problems. So he's about the argumentation and a lot of computation happening almost magically. So you draw something on the paper, system contextualize that immediately, and so on. And one of his talks was he dressed up like an engineer from 70s. He put these glasses, the t-shirt, and with the pencil here, and he used this beamer with the film slides to go over his presentation about it's 1971, and let's think how it could be in 30 or 40 years from now. What can computers do and things we can imagine. And he had a lot of funny jokes about the APIs and models and ways we process information, how computers work. And I think one of the takes from that was how people perceive the programming. And he told, we started with the punch cards, and the punch cards were very physical, very real, and you have to control every signal inside the machine using the punch card. And then there was these guys who came and told, let's do a little instructions behind it. Let's maybe a little bit virtualize this punch card world and do something like a machine code programs. And the punch card guys were like, no, punch cards is a programming, and the machine code is not a programming. Then the assembly guys came and they say, we can level up the machine code, we can create the loops and things, a little bit more sophisticated instructions. And again, they were not perceived. But with the time, we moved to the assembly. And then other crazy ideas pop up. There was the guy who brought this language Fortran and was like, let's use human readable language to create a program. And the assembly guy is like, oh my god, what he's doing. And I can only recommend to follow up and watch a few of his talks. Right. So that's a little bit of off topic. He has some prominent ideas and principles of how he creates his software. So coming back
do you think we miss some of that today? Do you think we're so in the weeds of doing stuff that we kind of miss the big picture?
It's a good question. In a way, it's hard to think so because I believe there's no shortcut, right? So we have to understand thousands ways it doesn't work before we know it works.
Right.
And he has with that a little bit satiric talk. He had a nice detour, and he pointed out a few things which could change the course of evolution of how we operate with machines. And let's see, maybe what he was imagining will partially be applied. For instance, he was reviving some models of working with the parallel programs like concurrency. And since I have the iOS background and following a lot Swift development topic, I can tell what he was calling out more than a decade ago is being actively implemented right now in the Swift 6 as a big milestone, and this difference between version 5 and 6 is the concurrency, and they basically use the same concept. It doesn't belong to Brett Victor, but what he did, he told, hey people, recently when he was playing about 70s, right? So we got this idea about how we can run software on multiple processors in a parallel manner. So, and now it's coming to modern languages. So, and the AI, which we are hyping today, we added a little bit from 70s, from 80s, right? But mostly we optimized and speed up some algorithms. We found maybe shortcuts or argumentation which helps to build better models, but mostly it's because of the amount of computation and memory we got.
Right.
We couldn't afford that much when the theory was born, and it came from mathematics.
Can we touch on that? Because that was one of the things I enjoyed talking about the other night, which was, I think we used I started with the concertina example and the processing time, and we talked about the automotive industry and the advancements there. You used the battery example, which I'd like to talk about, because I think there's an opportunity for machines to help us fine-tune and bring efficiencies to the way things are built and run. So the example I gave you the other night was I met a gentleman who's building a MIDI version of a concertina, which is it's a miniature accordion.
Yeah.
And he was using AI to write the code to reduce to optimize the processing of the note being played and the note being recorded by the sensors and then passed through the system. And that was very interesting. And you gave an example of the automotive industry and the battery power. So I don't know if you want to describe that again for folks. I think it was pretty cool.
Okay. So it took a big change for automotive in the last decade, and this change is switching from 12-volt batteries to 48-volt batteries, and the wiring and computers, sensors. So the machines used to run on 12-volt, and now if you bought a car after 2020, it's like most of the chances you'll get 48-volt machine. Even if it doesn't matter if it's like a Tesla or internal combustion engine, like, I don't know, Tesla, Dodge Corporation, whatever. So the thing is, we used 12 volt for so long, but we need a good material, good wiring with a high quality copper to run 12 volt through the machinery, through all the systems. Otherwise, the signal just doesn't go through. And if we, what we could do a long time ago is just bump the voltage up, because that reduces the requirement for the conductor material, and it saves like basically by quadrupling the voltage, you quadruple down the amount of copper you need to build the same car. We optimized the thing, and eventually we did it not because of the environment. It's because the price went up, right. I think. And the funny thing about 12 volt battery is the technology is more than 100 years old. It started like with the first cars, with the first batteries, when there would be like few wires inside and nobody actually care much about this part of the car, because there would be like almost no price added to the car, right?
Right.
And we built a huge supply chain for every manufacturer. So if you wanna change a thing like this, if you wanna flip a voltage, you're gonna flip the industry.
Yeah, not an easy decision to make.
Yeah, it's an expensive decision, but in the end of the day, the biggest car manufacturers did it. They started, I think, in 2014, and ongoing today, I think the most of them already converted. So it's kind of pressing the question of the real needs of the world, and the ideas can be different, but reality is right. Like it brings a lot of dependencies. And when we talk about AI, for instance, and we create something today, how much energy we burn. So when we generate the code, does it provide us like the efficiency we're looking for?
Yeah, I don't know if anybody's doing the analysis on the return on investment for.
I believe yes. There must be at least some AI model to do so.
There has to be. There has to be. The other thing I want to touch on, and I know we're kind of bouncing all over the place, but because that scenario is basically swapping out the electrical platform on the vehicles, right? And to support the capabilities needed and reduce the cost. We talked briefly about the idea of platform engineering, where companies can build a platform, maybe even providers of software and services could build a platform that everybody uses. Now we see it in the form of AWS and Kubernetes and those kinds of platforms, but I'm talking about all the way into the microservices and apps, and so we have a common ground from which we all run on. And I think you had I've been a fan of platform engineering because I think it brings consistency, it brings control, it brings to me a lot of positive things. But then you brought a counterpoint that I thought was very interesting around the ability, and it kind of goes back to the concertina example I gave, of the ability to have precision built things for specific tasks in specific environments, specific contexts, whatever. And Yeah, so your thoughts on, and I guess in reality, as an engineer, right? Deprecation is another thing you pointed out in that conversation. So.
Yeah. I think it's also related to the car batteries, like
right.
What it costs to deprecate 12 volts, and interesting reasons which push the thing forward. And also a question, is 48 volt is optimal, or it's a part of the deal which is a good trade-off between the problem we have and the next step to the solution. And the AI is definitely provides us additional tool. It can be used as a hammer, right? And if you don't know where to start, probably you start with a hammer. Then you master your hammer, you probably want to do a little bit of precision. And it's okay to explore the things. So again, when we say so much code can be generated, is it a bad thing? Is it a good thing? There would be like a friend of mine, he told, okay, there will be probably a profession like code sommelier or something like this, a person who would like taste the system in a way and validate it from the human perspective. Okay, is it functional or not? And if one machine writes the code, why we cannot add another machine which reviews it, and then machine which manages these machines and gives them assignments and tracks their progress. So basically all the things we do now in so many software companies. In theory, yes, this can be replaced. The question is like what we get, and also by solving this problem, won't we create any more problems? Like, won't we create a thing which provide us more tool for the world automation? Because everything we now interact with has a little bit of processing. I believe this core to the microphone has already chips inside. Somebody has to take care of this part of the system. The lighting in the house, your microwave. When I was a student, I've been talking to students from Seoul. They wanted to work for Samsung back then already, and they were exploring the world of smart devices, and they were telling, okay, chips will be everywhere, in your cup, in your in your shoes, in your clothes. Chips will be everywhere, and we kind of advance into that stage. We have something wearable, and we don't even touch in now the medical topic, right? Because some people will benefit a lot from augmentation in this area. Everything has to work, everything has to communicate, everything has to somehow to reach the coherence, and also in a way be understandable enough for human to rely on it. And I don't know how much more code we need. So on one hand, we already got a hammer. It can solve maybe with the hammer we can build a table, and with the table we can get a workplace to write a poem, a novel. That's the very beginning.
Right. Yeah, because what was it? I was watching the Euros the other day, and I noticed they were checking to see if there was a handball, and they pulled up a screen to watch this wave, a signal wave of the ball.
Okay.
In comparison to the video image, and they would show the person moving, and their hand near the ball, and then the signal from the ball, which clearly had a chip in it, would show that the ball had some pressure,
Okay.
which signaled that that the ball was touched by the hand.
Okay. Actually, now even the ball has a chip, right?
Yeah. Yeah. So different use cases. I want to, because you made up another interesting point. Do we have enough code or not? And before we were recording, you talked about the languages and LLMs and AI. So stick with the AI theme, because Dennis Cruz has a talk about deterministic Gen AI outputs with provenance, and I'm going to connect these points together, which is we have data, we have code, we're building more models to help analyze this stuff. It's going to come to a point where, where's the data from? What model generated the output? Is the output accurate? How do we verify that? Is that human-based? Can we use other machines and LLMs to do that? And then, so there's that whole picture there of what is it, who created it, what created it, what's the output, is it accurate, can we rely on it, what do we do with it? And then your point earlier before we started recording was that's the language that we speak, we type,
Right.
we have thoughts, we visualize things, we see things. Where do you see things headed in that regard, which obviously different languages just from different countries as well, but we're talking about language that could be sound and visual and voice and writing and thinking and coding and blah 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 blah. It's an interesting future ahead of us. What do you see happening there?
Yeah, we were talking a little bit about how we got the machines, the LLM machines now. So basically we build them by feeding all the text there. And in return we get in the model which can reliably predict the next word and phrase and generate a very likely real and truthful output. And the thing is built completely on the language, which we also use. And the language is a powerful tool. It's probably helped human brain to evolve to the state where we are now, and probably helping us to move forward. And there is now a theory which says maybe yes, and maybe to move forward we should also free ourselves from the limits of the language, because it provides the power, but it also limits by its own construct the imagination. So at one point we contributed to build the language model out of our language. On the other point, the output we get would be always limited by this language. It's not as horrible as it sounds, because
That's very interesting. I mean, we can bring it back to the battery. Battery, right?
Yeah.
You can bring it back. I think and earlier you mentioned the the steam engine turning to combustion.
Yeah. There was like a period of history very short when we had the steam engine, and it had its own evolution. So the first steam engine was definitely not as advanced as the modern steam engines. Even today we have working models, and for some situations the steam has a lot of power, and today we kind of mastered it to a certain extent. So we cannot compare it to 18th century. But there was a time when we peaked with the steam engine power, and we had to move on. We started to use combustion engines, we started to use electric engines, and Steam went down. So if we would run on Steam, we would need so much energy now.
Right.
We would need to burn so much stuff and so on. But it helped us. It helped us to advance a little bit to burn oil, yeah, and gas. And the language itself is also a tool, right? It just has a bigger historical span, and we probably use tens of thousands of years, maybe 100,000 years. We use the language. It evolves all the time as we evolve in, and or we evolve in as we evolve the language. And at certain
the chicken or the egg.
Yeah. And at certain point, there will be the language might become a limit, and we have to change something to move on. So we have not only language models, but we have similar technology for signal recognition, video processing, etc. So code generation and things with the code is language, right? So
we'll be limited by what we know already.
Yeah. That's a classical thing. It's not too bad.
Yeah. And the other point as we wrap here, because I think kind of to the combustion engine, and that reached the limit of power. It takes too much energy to produce the power that we need out of that, so we had to switch. And I know we're using electricity a lot for AI and Bitcoin, you name it, right? And as everything becomes connected, IoT devices and sensors and cars and footballs and shoes and whatever else, that's all going to require power or energy. And I don't know, it's just a feeling I have that we're going to reach a point where we don't have enough power to run all this stuff. And that may be a shift as well, where we need to change how we create an environment in which we live. I don't know. Interesting.
Yeah. I was even trying to compute at some point if that would make economical sense to actually launch these solar panels in the space and launch the computers. Probably, I don't know, maybe we will have cooling issues there, but it feels like maybe easier to radiate heat from the computers, and the more advanced computers we have, like in our phones, already not that heat intensive. So basically we can mine bitcoins or mine computation using solar energy, and maybe that can help us to offset. So we can. There's a lot of questions. How we deliver this amount of solar panels into the space, how much it would cost, and how much we have to burn to get it there. Right.
Yeah, there's that too.
We still have to burn.
You need the desk built by the hammer first.
Yeah. And there was a book from Suarez, I think, about the asteroid miners. Delta V. It's like, in short, he provides a little bit of perspective what it makes to get material into the space, like how to get it there. He tried to think of what it makes to a human to reach the asteroids, or something which within our technical capacity to get all the materials, the resources, and bring it like closer to the planet. How much it would cost, like if it be orbiting our planet? Because now we build stuff and then we launch. Of course, we cannot afford ourselves to launch raw material and build in space. Right. And if we want to expand, we probably have to dig in the moon. Is it something happening already, right? There's like a few programs to build some factories on the moon.
I know there's a view for that. I was reading last night that there's the plan is to decommission the International Space Station and open that level of space for the private sector to open hotels and stuff. I guess if you want a holiday there.
Still be cheaper than the hotel in New York, I believe.
That's right. Probably true. Oleg, well, we touched on many things here. I don't know. Hopefully people follow along. I think they certainly, hopefully, made people think a bit. A lot of fun topics here. An absolute pleasure meeting you, and a joy talking to you today. And hopefully you'll be back on the show. I think some of this philosophical stuff Marco would love to chat about as well. So maybe we'll have you on with Marco too, my co-founder, and we'll explore some fun things. But hopefully we didn't talk too much security. I think the main thing is you want all this stuff to stay up and running and have integrity. So availability, integrity for sure. Confidentiality and privacy obviously comes into play in certain circumstances. But
thanks, Sean. To add a few words about the security, I think for the first day, I have to appreciate Martin's words. Like, if you want to have the security, you want actually to have quality testing. You have to have reliability. You have to have engineering at certain level. So of course we talk about the software security and system security in software space. And you cannot just go there. It's like
it's not
skipping the steam engine is not possible. No. There's no shortcut.
No shortcut. That's a good point. No shortcut. It's not magic. You don't just arrive and it's done. It takes some work. It takes this community, and I'm thankful OWASP brings folks together that are thinkers like you and doers, and bring us all together to find that path beyond the steam engine.
Right.
Yeah, a safe one. We all survive happily ever after. All right, Oleg, thanks for the chat. Thanks everybody for listening. I'll try to dig up a couple of things that we referenced during our chat and put links in the notes for that. And appreciate everybody listening, and see you on the next episode. Lots more from OWASP AppSec Global in Lisbon coming your way. Ciao.
Ciao.
We hope you enjoyed this episode of Sean and Marco's on-location event coverage conversations. Please take a moment to give the show a good rating and leave a comment. Remember to share this podcast with your friends, family, and colleagues. Come back for more conversations and follow Sean Martin and Marco Ciappelli as they continue their journey toward redefining cybersecurity and society.